We're going to look at literal equations, which really simply means solving for a variable in terms of another variable. So we have two variables here, and what we're going to do is we're going to solve for y, because that's what it says here. What that means is move everything to the other side. And you do it sort of in the opposite of the order of operations. So here you see 2 times y, but because it's multiplication, we're going to take care of this 3x first and subtract it from both sides. Now, I'm going to give you a little hint. Two things, actually. One of them is you don't have to do this kind of a thing where you write it underneath. But I highly, highly, highly recommend that you do, because it's really easy to make mistakes with negatives if you don't. And many times what people will do is instead of subtracting 3x, because they don't do this part written down, they do it in their head, and they end up putting the 3x on the other side without making it negative. Okay, the second thing is if you have just y and x, put the x term right after the equal sign, because that ends up putting it essentially into y equals mx plus b order, or the slope-intercept form, which is useful in graphing. So in this case, by putting it right there, it'll already be in that form. If you're just told to solve for y, then putting the negative 3x after the 8 would still be acceptable, but it's better this way. Now I'm going to divide by 2. Okay, and over here, I want to show you 2 ways to do it on the other side, both of which are correct, but one of them is dangerous. Many people put it like this. Some people put it like this. This is by far the best way to do it. Because if you put the 2 underneath each one of them, then you'll have a 2 in each fraction, which is what you're supposed to do. But sometimes people do here is they put the 2 with only one thing, and they do minus 3x plus 4, which is wrong. Because the 2 has to go with both things because of them being separate terms. And people tend to forget that and make a mistake. So don't do it this way. Don't do it this way. If you do it that way and get it correct, I won't complain. But sometimes you're going to do it that way and you're going to get it wrong, and well, then that's probably not the best thing for you to do if you want to do well in the class. So now the 2's cancel here, and I get a 2, or I get a y, I mean. I cancel that out. Here, I have negative 3 over 2, and it's best to put the x there, next to it, plus 4. What I have now done is to solve for the variable y. There's one other little hint thing that I want to bring up here, and it is, look at the ways that I could write with the x. I could also do this. Okay, it's dangerous to do it with that, so I don't recommend it. And the reason it's really dangerous is because what many people do is they do this. And they mean for it to be negative 3 over 2 times x, but what it ends up looking like, because they're not very careful with how they write it, is they make it look like that, which is then what most people think of that is negative 3 over 2, and it's as if the x is on the bottom. So this is wrong, and this is wrong. So this is dangerous. Please don't do it that way. Don't use the slash for your fractions, because it makes it seem as if the x is in the wrong place. Just not all the time, but sometimes you forget yourself. So I don't recommend to do it. So this is best. By far, that's the best way to always do it. Okay. Now we're going to solve for y with a different type of thing with it. Oh, let's first. Okay, there. Now, in this next one, we're going to solve for y. And what's going to happen here, actually, is that first, we're going to take care of fractions. So this problem illustrates something different. We're going to multiply both sides by the lowest common denominator to get rid of that. You don't have to, actually. You could do it without it, but it's very... In fact, let's do it the long way and the hard way. I see an 8 and I see a 4. So I know that if I multiply on this side by 8 and I multiply on this side by 8, I'll be able to take care of those fractions. So I have 8 times 3 over 8x minus 8 times 3 over 4y is equal to 96. So these 8's cancel out, and I have a 3x. 4 goes in 8 twice, so that makes it minus 6y equals 96. I'm still solving for y here, so I'll need to bring the 3x to the other side. Subtract 3x, subtract 3x. Negative 6y equals negative 3x plus 96. Okay, and now when I divide by the negative 6, and again I'm going to do it the right way underneath each one of the things. So I get my y. The negatives cancel out, and I have 1 over 2 times x. So it's a 1/2. And then a plus and a minus makes for a negative. And it's 16 times that 6 goes into 96. So look at the steps that I did there. And first one was multiplying all sides by the 8 and subtracting the 3x on both sides. And it was dividing by the 96, dividing by the negative 6. Right? And all of that gave me this form. Now what I could have done, longer and I think more difficult. But some people do this because they just don't think about multiplying by the 8. 3 over 8x minus 3 over 4y equals 12. What they'll do is subtract the 3 over 8x on both sides. 3 over 8x. So they get negative 3 over 4y equals negative 3 over 8x plus, let's see that right, plus the 12. Okay, plus the 12. Here the problem is many people don't know what to do with the fraction. So they try to do some weird thing where they try to divide by negative 3/4. Okay, so if you try to do this where you try to divide by negative 3/4, although that's possible to do, it's very confusing in almost every way. Okay, so that's the first thing is, I'll actually write that. Is confusing for almost everybody. Some of you know you could do it and get away with it and do just fine, but it's still a lot more work than this is over here. The other way to do it is to multiply both sides by the reciprocal. So let me write this out again. So what I would do is I multiply by the reciprocal with that same sign, but I would do that to each term. Multiply 4 over 3, and that's a 12 there. So I'd be multiplying that by negative 4 over 3. When you do that, you would get y by itself, and here you would get positive 1/2 x, and here after you're done with all the work in it, you would get the same 16 that you got in the other problem. So you would get the correct answer, but it would be a good deal more fractional. So if you want to avoid fractions, do it this way. This is the best method. I don't care if you do another method if you can get it correct and you can write out all the steps correctly, but it is longer and more difficult to do the other method. All right, now let's take a look at one here where it's a definitely more complex type of problem, and we're solving for one particular thing. More than any other problem, this kind proves that you know or don't know your order of operations. So when I look at it, if I want the x by itself, I want to get everything else to the other side. So I'll start by, like opposite of order of operations, I'll start with 5r squared. So I'll add 5r squared to both sides. A plus 5r squared equals 7xr over 2. So now at this point here, first thing is to recognize that you don't have to do anything with the stuff that's over here. You just let it sit next to each other. That's the point of the variables. They just stay next to each other unless you know what one of the numbers are. All right, now what we can do here, I see a fraction. So the easiest thing to do with a fraction is to multiply both sides by a 2. And that means 2a plus, or by the bottom part of it, by the denominator. If I multiply by the denominator, I just took care of that denominator, nice and easy, and now there's no more fraction. Oh, except that there's going to be, because if I want the x by itself, I'm going to have to divide by 7 to cancel that out. I can also divide by the r. So I'll do 7 over r. So now I'm going to put the x first here. And so I have 2a plus 10r squared over 7r. This would be an acceptable answer. However, if I were to put the 7r with both things, like you're going to see, I'm going to get x equals 2a over 7r plus 10r over 7. Because for the second step, we have 10r squared, which is r times r, over 7r. So two of those r's would cancel. So this, because one of them could be reduced, this is a good answer. However, because only one of them can be reduced, this is an acceptable way to do it too. So both of those would be considered acceptable. Right. I hope that helps for part of this section. And thank you for watching and listening.